taps A and B can fill a tank in 20 and 30 minutes respectively, while the third tap C can empty it in 40 minutes. All right, so it's about 3 taps here, A, B and C. A and B, right? Tap A and tap B can do the positive work, which is filling the tank in 20 and 30 minutes respectively, whereas C can empty it, right, in 40 minutes. All 3 taps ran for 5 minutes. So all 3 were kept open for 5 minutes with full efficiency, right? Full efficiency. And then tap C got closed. Tap C got closed after 5 minutes. And due to dust, the efficiency of tap B becomes 2 by 3, right? It should be becomes actually, right? The efficiency of tap B becomes 2 by 3. Efficiency is nothing but capacity. You can say efficiency or capacity. So the efficiency or capacity of tap B becomes 2/3 due to dust. In what time approximately will the tank get filled is the question. In what time approximately will the tank get filled? First of all, let us find out how much of work will get over in the first 5 minutes, right? What happens in the first 5 minutes? In the first 5 minutes, all 3 are running. All 3 are running. So what happens in first 5 minutes? Let's calculate. First 5 minutes. Let us first calculate the capacity of all the 3 pipes together. So the first tap can do 1 by 20th of the work in 1 minute. Second tap can do 1 by 30th of the work in 1 minute. The third one will do 1 by 40 and minus 1 by 40. Why? Because it is emptying the tank. So you have to take negative sign here, right? This is like any regular calculation that we do. Now simplify this, what happens? The LCM is 120, right? So 6 times, 4 times, minus 3 times. How much do we get? 10 minus 3, 7 by 120. Which means all these 3 taps together can do 7 by 120 of the work in 1 minute. In 1 minute. Yes or no? They can do 7 by 120 of the work in 1 minute. So how much will they do in 5 minutes? Multiply by 5. See, this is the amount of work that they can do in 1 minute. So how much will they do in 5 minutes? 7 into 5 by 120 in 5 minutes. Because why are we considering 5 minutes? The first 5 minutes here, right? So 7 into 5 by 120. How much is that? 35 by 120. So the completed work is how much? The completed work is equal to 35 by 120, which is 7 by 24, right? 7 by 24. Implies what is the remaining work? Work here is nothing but the filling of tank, right? Remaining work. So you know that total work is always 1 unit. So 1 minus 7 by 24. You don't have to do all this nautanki in the exam. Cut down the number of steps. I mean, you can cut down a lot of calculation related steps here. So 1 minus 7 by 24. How much will that be? You're able to follow. 7 into 5 by 120. So if you simplify that, we will get 35 by 120, which is 7 by 24. 1 minus 7 by 24. So this will be 17 by 24. This is the remaining work. 17 by 24 of the work has to be done. Now, who will do this 17 by 24 of the work? Only A and B, because tap C got closed. After 5 minutes, tap C got closed. And also, efficiency or the capacity of B becomes 2 by 3. See, remember, we have learned that capacity and time are inversely proportional to each other. Capacity is inversely proportional to time. So if capacity becomes 2 by 3 or efficiency becomes 2 by 3, time will become 3 by 2. Yes or no? Usually tap B takes 30 minutes to fill the tank. But when the capacity becomes 2 by 3, for tap B, capacity becomes 2 by 3. Implies the time required by tap B now, time required by tap B now to do the work will become 3 by 2 times. 3 by 2 times of what? The original time, 30 minutes. Capacity becomes 2/3, time will become 3 by 2. 3 by 2 into 30 is how much? 45 minutes. So now for the remaining part of the work, you must consider that tap B will take 30 minutes to fill the tank. You're able to follow? For the remaining calculation, we will not take 30 minutes. Now it has become 45 minutes. And tap A remains 20 minutes only. Now understand, now we have got 2 new taps. Tap A, which takes 20 minutes, and tap B dash, I would say, which takes 45 minutes. Find out how much time will both of these taps together take to fill the full tank. Let us first find out the time required for filling the full tank, right? So to do 1 unit of work, how much time? AB by A plus B. So 20 into 45 by 20 plus 45, which is 65. For how much work? 1 unit of the work. See, total work is always 1 unit. So they'll take 20 into 45 by 65. So this is like 9 times, this is 13 times. So 180 by 9 to 20 into 9 is 180. 180 by 13 implies they will take 180 by 13 minutes for doing full work, 1 unit of work. But how much of work they have to do? They have to do only 17 by 24 of the work, because the remaining is only 17 by 24. So for doing 17 by 24, how much time will they take? Can you cross multiply? Yes, you can cross multiply, because on one side we have work, on the other side we have time. These are directly proportional to each other. So you can do cross multiplication. So what will be the question mark here? The question mark now will be equal to what? 17 by 24 into 180 by 13. Simplify this. This is 12 into 2, 12 into 15. So 17 into 15. How much is 17 into 50? 170 plus 85. 255. 255 by 2 into 13 is 26. 255 by 26. 255 by 26. 255 by 26. Approximately 10 minutes. 260 by 26 is 10, right? This is approximately 10 minutes. Right? Now, what is the question? In what time approximately will the tank get filled? 10 minutes here plus 5 minutes here. These two. 5 minutes for doing this much work. 10 minutes for doing the remaining work. Are you able to follow? So 10 plus 5, 15 minutes. Approximately 15 minutes. Total time required. Approximately 5 plus 10. 15 minutes. Little less than 15 minutes. Because 255 by 60 will not be 10 exactly. It will be less than 10. So less than 15 minutes. So option B, option C and option D gets eliminated. Option A would be the answer.
A manufacturing job was wrongly estimated to be completed in 10 days by X machines, right? So very clearly there were X machines and it was estimated, right? And remember, wrongly estimated that it can be completed in 10 days by X machines, which means actually it cannot be completed in 10 days, right? By deploying 3 extra machines, the job was completed in 12 days. So when they use 3 extra machines, they could complete this job in 12 days. So instead of X, they have used X plus 3 and they could complete the job in 12 days. If only one additional machine was used, remember, they have actually used how many additional machines? 3 extra machines. But the question now says if only one additional machine was used instead of 3, then how many more days or how many days more than that estimated time would it have taken to complete the job? You getting it? If only one machine was used extra, how many more days would it take to complete this job? Now understand, what is total work? Total work, like we have discussed in the video, is number of persons into number of days. In this case, person is nothing but a machine. So number of machines doing the work into the number of days for which they work. Now you cannot say total work is 10 into X. This would be wrong because it was a wrong estimation. Remember, that actually the work cannot be completed in 10 days by X machines. Right? So you cannot say work is equal to 10 into X. Don't do that. The actual work is how much? X plus 3 into 12. Because by taking 3 extra machines, so X plus 3 machines, they could finish it in 12 days. So we can say the total work is 12x plus 36. This is the total work, 12x plus 36. Now, if only one additional machine was used, how many days more than the estimated time would it have taken to complete the job? Now, what happens if only one additional machine is used? The other case, I mean, this is one case. In the actual case, 12 machines could finish, X plus 3 machines could finish in 12 days. But what happens if only one additional machine is used? We can say the work, total work W will be X plus 1. We don't know how many days would it take. Let us assume it is D days. The total work will be X plus 1 into D. Only one additional machine being used. So X plus 1 multiplied by D. Yes or no? X plus 1 being multiplied by D. Now the point is 12x plus 36 represents the total work. X plus 1 into D also represents the total work. So from these two, we can conclude that 12x plus 36 is equal to X plus 1 into D. Or we can say the number of days required when only one machine is being used will be 12x plus 36 divided by X plus 1. Remember, this is number of days. What we have calculated here is number of days, right? Total number of days. All right. But what is asked in the question? How many days more than the estimated time would it have taken to complete the job? The total number of days that it takes when only one machine is used, when extra machine is used, would be 12x plus 36 by X plus 1. But it's not asking us to find out the total number of days. It's asking us to find out the number of days more than the estimated time. What is the estimated time? 10 days. So the additional days, right? Additional days can be taken as D minus 10 because estimated time was 10 days. So from total days, if you subtract 10, you get the answer. So 12x plus 36 upon x plus 1 minus 10. So what happens? 12x minus 10x. 2x, 36 minus 10, 26 divided by x plus 1. So 2x plus 26 divided by x plus 1. 2x plus 26 divided by x plus 1. Option 3 would be the answer.
A set of 10 pipes, set X, can fill 70% of a tank in 7 minutes. Another set of 5 pipes, set Y, fills 3/8 of the tank in 3 minutes. And a third set of 8 pipes, set Z, can empty 5 by 10 of the tank in 10 minutes. Now, if one pipe is added for set X and set Y, and set Z's capacity is increased by 20% on its original value, and all the taps are opened at 2:58 p.m., then at what time does the tank get filled? Right? So if you look at the question here, it says there are 3 sets. Set X, which is a set of 10 pipes, and it can fill 70% of the tank in 7 minutes. Then there's set Y, which is a set of 5 pipes, and it can fill 3/8 of the tank in 3 minutes. And then there is a third set of 8 pipes, which is set Z, and this can empty the tank, right? Empty 5/10 of the tank, 5 by 10 of the tank in 10 minutes. Now, if one pipe is added for set X and set Y, now see, set X has got 10 pipes, set Y has got 5 pipes. He says one pipe is added to set X and set Y. So 10 pipes will become 11 pipes, 5 pipes would become 6 pipes. And set Z's capacity is increased by 20%. Whatever is the capacity of set Z, see, currently the capacity of set Z is, it can empty 5 by 10 of the tank in 10 minutes. Its capacity will be increased by how much? 20%. Right? Set Z's capacity will be increased by 20% on its original value, right? So whatever is the original capacity, it would be enhanced by 20%. And then all the taps are opened at 2:58 p.m. Then at what time does the tank get filled? So see, the last part of the question is very simple. He says all the taps are opened simultaneously. At what time will the tank get filled? Or how many minutes will it take for the tank to get filled? Don't get confused with this 2:58 p.m. and the given options there. All you need to do is find out how many minutes will it take for all the 3 sets to fill the tank. And those many minutes, if you add to 2:58 p.m., you'll get the required answer. Is that clear? I hope yes, right? So the question is very clear. 3 sets of pipes. First set has got 10 pipes, it can fill 70% in 7 minutes. Second set has got 5 pipes, it can fill 3/8 of the tank in 3 minutes. And third set has got 8 pipes, it can empty 5/10 of the tank in 10 minutes. Alright? And then one pipe is added to set X and set Y, set Z's capacity is increased by 20% each, and all the taps are opened at a particular time. So, and what time does the tank get filled? So the point that I'm trying to make here is that you need to understand the question very properly, right? If you have understood the question, I think half of the problem is done, right? I'm sure many of you would have got struck in understanding what the question means. So if that is clear, then you can proceed with the solution. All right. Now, the points to be noted here, I mean, there's not, this has only been made lengthy in terms of the number of sentences given. But as such, if you see, it's not very complex, because he says a set of 10 pipes can fill 70% of the tank in 7 minutes. See, if 70% is filled in 7 minutes, 100% will be filled in 10 minutes. Are you able to follow? Set X can fill 70% in 7 minutes. So can we conclude that set X, which has got how many pipes? 10 pipes, right, will fill the tank in 10 minutes? Yes or no? 70% is 7 minutes. All these 10 pipes together, they can do 70% of the work in 7 minutes. So obviously 100% they will do it in 7 minutes. Similarly, if you look at set Y has got how many pipes? 5 pipes. Set Y has got 5 pipes and it can fill 3/8 of the tank in 3 minutes. Understand? 3/8 is like 3 parts. The work has been divided totally into 8 parts, right? 3 out of 8, right? So total work is 8 parts, of which 3 parts can be done in 3 minutes. What's the total work? Total work is to fill the full tank, right? The full tank is 8 parts. So if 3 parts can be done in 3 minutes, can I say 8 parts will be done in 8 minutes? See, no need to write steps on paper for that. 3 parts can be done in 3 minutes. So obviously 8 parts would be done in 8 minutes. Or you do cross multiplication. 3 by 8 of the work can be done in 3 minutes. So 1 unit of the work will be done in how many minutes? When you cross multiply, you will get 8 minutes. So I can say that set Y can actually do the work in 8 minutes. Alright. Then third set of 8 pipes, which is set Z. It has got 8 pipes, right? Now this can empty. Right, it is doing a negative work. Remember, it is doing negative work. This is a positive work. This is a positive work. This is a negative work. Alright, X and Y are doing positive work. Z is doing a negative work. It is emptying the tank. It can empty 5 by 10 of the tank in 10 minutes. What do you mean by 5 by 10? 5 by 10 is half.
Half of the work can be done in 10 minutes. So full work will be done in 20 minutes. So this will be taking 20 minutes. Of course, you can cut down these steps further. I am only writing these statements here so that you can follow it clearly. You need not put pen on paper for this also, right? You can directly write 10 minutes here, 8 minutes here, and 20 minutes here, right? Now see what happens. Now we need to do some changes. He says one pipe is added for set X and set Y. So in set X and set Y, we'll add one pipe, and set Z's capacity will be increased by 20%. Now the point is this: 10 pipes can fill the tank in 10 minutes. 10 pipes can fill the tank in 10 minutes. When one pipe is added, it will become 11 pipes. Are you able to follow? 10 pipes. Currently set X has got 10 pipes. They can fill the tank in 10 minutes. If one pipe is added, so it will become 11 pipes. If 11 pipes will take how many minutes? Don't say 11 minutes. I'm sure at least a few of you would have got 11 minutes as the value immediately, right? 10 pipes can do in 10 minutes. 11 pipes will do in how many minutes? Do not say 11 minutes, because this is not directly proportional. Understand, here pipes is like men. 10 pipes is like 10 men, and this is time. So if 10 men can do the work in 10 minutes, 11 men will do in less than 10 minutes. Are you able to follow? If 10 men can do in 10 minutes, 11 men will do in less than 10 minutes, right? So you cannot say 11 minutes there as the answer. If the workforce increases, the time taken will reduce. Yes or no? When the capacity increases, 10 pipes is becoming 11 pipes means what? The capacity has increased. If the capacity has increased, the time taken will reduce. Same applies to the second set also, set Y. He says here also one pipe is increased. If the pipe is increased, number of pipes is increased, the time taken would reduce. Are you able to follow? So keeping that in mind, how do you get it? 10 pipes takes 10 minutes. 11 pipes will take how many minutes? 10 into 10 by 11. Yes or no? You know that number of men into number of days is always constant. I mean, is equal to the work. So here, number of pipes into time taken. Number of pipes into time taken should be balanced on both the sides. So I can say the new set, let's say X dash, which has got 11 pipes, will take how much time? 10 into 10 by 11, which is nothing but 100 by 11 minutes. Yes or no? Similarly, the new set Y dash, it will have how many pipes? 6 pipes, right? One pipe is added. Now 5 pipes could do in 8 minutes. So the work is 5 into 8, and this has to be done by 6 pipes. So it will become 40 by 6. 40 by 6. So 100 by 11 is the time taken by set X dash, which is the new set, and 40 by 6 is the time taken by the set Y dash, right? The new set, 40 by 6. Now, in the third set, we are not adding pipe. We are increasing the capacity by 20%. We are increasing the capacity by 20%. What do you mean by increasing the capacity by 20%? See, increasing capacity by 20% means what? Increasing the number of pipes by 20%. If you increase the capacity by 20%, number of pipes will increase by 20%. See, there are two ways of looking at it. When you say capacity is increased by 20%, there are two ways in which you can increase the capacity. Either increase the number of pipes. If you increase the number of pipes, the capacity will automatically increase, right? Or increase the capacity of each of these pipes, right? So what can you do? Either increase the number of pipes by 20%. So 8 pipes will become 8 plus 20% of 8. Or increase the capacity of each of the pipes. Like for example, let's say each pipe here can fill 100 liters in 1 minute. So increase the capacity by 20%. So it will fill 120 liters in 1 minute. You're able to follow. So either increase the size of each of the pipe, size meaning the cross section of each of the pipe, or increase the number of pipes, whichever is convenient to you. I think better we go by increasing the number of pipes. See, both will result in increase in capacity, right? So I can say Z dash will have how many pipes now? 8 plus 20% of 8. What is 20% of 8? 1.6. See, these calculations you must not put pen on paper, right? Only then you can solve these questions quickly. Otherwise it would look lengthy. So 8 will become 8 plus 1.8, which is 9.6. See, I'm not writing all those intermediate steps here, right? 9.6 pipes. So 9.6 pipes will take how many minutes? 8 pipes to 20 minutes. 8 into 20 divided by 9.6. Simplify this. So this is like 1 by 12, or I can say 200 by 12, right? 200 by 12, right? 8 into 1, 8 into 1.2. So 20 by 1.2, which is 200 by 12. 200 by 12 minutes. That's it. Done. Now it is like this. One pipe can fill the tank in 100 by 11 minutes. The second pipe can fill the tank in 40 by 6 minutes. The third pipe can empty the tank. Remember, Z is emptying the tank. It can empty the tank in 200 by 12 minutes. If all three are working together, all the taps are opened at 2:58 p.m., then how much time will it take to fill the tank? What do? You know the unitary method, right? If time taken is this, what is the capacity? Total time required. If all the three are working together, how do you get the total time? You take the sum of their capacities. So 100 by 11 minutes, capacity is 11 by 100. plus 40 by 6 minutes, capacity is 6 by 40, minus, remember we should take minus because it is doing negative work, right? 200 by 12 minutes, so the capacity is 12 by 200. Simplify this. What is LCM? 200 is LCM, right? So 100 goes 2 times, it will become 22, 40 goes 5 times, so plus 30, right? And 200 is anyway 1 time. So 22 plus 30 minus 12, which is like 40 by 200, right? 40 by 200 is how much? 1 by 5. 1 by 5 implies, see, total capacity of all the 3 pipes together, total capacity of all the 3 pipes together is 1 by 5, which means time taken is how much? 5 minutes. You know that time taken is reciprocal of the capacity. So if the total capacity is 1 by 5, time taken will be 5 minutes. They started at 2:58 p.m., right? Plus 5 minutes will be equal to what? 303. Yes or no? Option D would be the answer.
A tank has an inlet and outlet pipe. The inlet pipe fills the tank in 2 hours when the outlet pipe is plugged. The outlet pipe empties the tank in 6 hours when the inlet pipe is plugged. So I hope all of you have understood what it means, right? When the inlet pipe is working alone, outlet pipe is plugged means what? It is closed, right? Pipe is plugged meaning pipe is closed. So when the outlet pipe is closed, the inlet pipe will fill the tank in 2 hours. Similarly, when the inlet pipe is plugged, when the inlet pipe is closed, the outlet pipe will empty the tank in 6 hours. So this is like a regular case. A tank has got 2 pipes. One is an inlet, the other is an outlet, right? The inlet pipe can fill the tank alone in 2 hours. The outlet pipe can empty the tank alone in 6 hours. Alright. Now, see the first part of the question, right? Part A. It says, if both the pipes are opened simultaneously at a time when the tank is 1/3 filled, when will the tank fill thereafter? So already the tank is 1/3 filled, right? 1/3 of the tank is filled. 1/3 of the tank is filled. The remaining 2/3 have to be filled. The 2/3 have to be filled. So how much time will both the pipes take? Remember, both the pipes are opened simultaneously at a time when the tank was 1/3 full. So 1/3 is full. Now if both are opened simultaneously, this is unplugged, that also is unplugged. So how much time will it take thereafter to fill the tank? Nothing to worry about what is given in this question there. First of all, find out how much time will both the pipes take together. See, the first pipe's capacity is 1/2. The second pipe's capacity is minus 1/6. Why are we taking minus 1/6? Because it is doing negative work. Remember the concept of pipes and systems. This pipe is doing a positive work. The second pipe does negative work. So the first pipe's capacity can be taken as 1/2 and that of second pipe can be taken as minus 1/6, negative capacity. So find out the total capacity. 6 is the LCM. 3 times minus 1 time. So 2/6, which is equal to 1/3. So I can say, or we can say, overall it takes 3 hours. 3 hours to fill the full tank. Right? Full tank. But remember, the pipes were unplugged, both the pipes were opened when the tank was already 1/3 filled. Already 1/3 of the tank is filled. Only 2/3 have to be filled now. So for filling the full tank, it takes 3 hours. For filling 1/3 of the, for filling 2/3 of the tank, it will take 2/3 of 3 hours. You getting it? So 2/3 of the tank is how much? 2/3 of 3 hours is how much? 2 hours. That's your answer. Are you able to follow? Very, very simple. I mean, nothing complex about it. For filling the full tank, they take 3 hours. For filling 2/3 of the tank, they'll take 2 hours. 2/3 of the time. So 2 hours should be the answer. So first part of the answer should be 2 hours. So option B and option D get eliminated. Now look at the second part of the question, right? What is the second part of the question? It says there is a leakage also which is capable of draining out the liquid from the tank at half of the rate of outlet pipe. So there is another outlet pipe now, leakage. See, leakage, like we have discussed in the concepts of time and pipes and systems, is like outlet pipe, right? A leakage will empty the tank. So it can be taken as an outlet pipe. Now here, he says there is a leakage which is capable of draining out the liquid from the tank at half of the rate of outlet pipe. So let's assume that here is a leakage. And because of that leakage, water is dripping out. Right? Now the capacity of this leakage is half of the rate of outlet pipe. Now if the capacity is half, time taken would be double. We have discussed this already. Capacity and time are reciprocal to each other, right? So if the capacity of this outlet, this leakage is half of this one, the time taken will be double. So if this takes 6 hours, this would take 12 hours. Why? Since capacity is half. Capacity is half implies time taken would be double. So now it is like 3 pipes. One is an inlet which takes 2 hours. 2 are outlets.
which takes 6 hours and 12 hours respectively. So then what is the time taken to fill the empty tank, right? Fill the empty tank. Now it is not 1/3 full like in the previous case. It is an empty tank when both the pipes are opened. Both the pipes are opened, and remember, leakage is anyway there. Again, you should not get confused that leakage is opened or not. Leakage is never opened. It happens by itself, right? So he says both the pipes are opened. Leakage is anyway draining out the water there. So what happens in this case? Positive is 1/2. There are two negatives, 1/6 and 1/12. Simplify. 12 is LCM, so 6 times, 2 times and 1 time. So this is like 3/12 or 1/4. Implies 4 hours is the time. The total capacity of all three together is 1/4. So time taken will be 4 hours. Right? Option C would be the answer.
Bath can be filled by cold water pipe in 40 minutes and by the hot water pipe in 60 minutes. A person leaves the bathroom after turning on both pipes simultaneously and returns at the moment when the bath should be full. Finding, however, that the waste pipe has been opened, he now closes it. In 12 minutes more, the bath is full. In what time would the waste pipe empty it? In what time would the waste pipe empty it? Right. So if you read and understand the question, important parts of the question, he says there is a bathtub, let's say, which can be filled by the cold water pipe in 40 minutes and by the hot water pipe in 60 minutes. So there are two pipes here, pipe A and pipe B, like our usual case, right? So one pipe takes 40 minutes to fill the tank or the tub, and the other pipe takes 60 minutes, right? Takes 60 minutes. Now a person leaves the bathroom after turning on both pipes simultaneously, right? You have turned on both the pipes simultaneously and returns at the moment when the bath should be full. He returns at what moment? He returns at the moment when he knows that the bath should be full. So basically we have to find out, first of all, how much time will these two pipes together take to fill the tub, to fill the bath. You're able to follow? I mean, this person also knows that it takes so much time to fill the bath, so he returns at that moment exactly, right? Now you know that when two pipes are working together, or when two persons are working together, A and B are working together, the time required by both A and B together is AB by A plus B. I mean, that's like the shortcut, right? AB by A plus B. Or you can do 1 by A plus 1 by B. So let's say the pipe A here takes 40 minutes and pipe B takes 60 minutes. So when both of them are working together, the time required will be AB by A plus B, right? So simplify this, 40 into 60 upon 40 plus 60. So how much is this? 40 into 60 is 2, I mean, this denominator is 100, right? This, let's say it's 100, 40 plus 60 is 100. So zeros get cancelled. We are left with 4 into 6, 24. So the idea is that when both the pipes are open simultaneously, cold water pipe and the hot water pipe are open simultaneously, it takes 24 minutes to fill the bath. Now this person returns at the moment when the bath should be full. That means he returns after 24 minutes, right? He returns after 24 minutes. At the moment when the bath should be full can be replaced with after 24 minutes now, because the bath should be full after 24 minutes. What does he find? After returning, he finds that the wastewater pipe has been opened. There was another pipe, the wastewater pipe or the waste pipe, which was open, which was left open, and he now closes it. So he realizes that one more pipe has been kept open, waste pipe. And remember, waste pipe is an outlet. The first two pipes are an inlet. The cold water pipe and the hot water pipe are inlet pipes, but the waste pipe is an outlet pipe. So that waste pipe has been kept open and he now closes it. He has now closed the waste pipe. In 12 minutes more, so from now onwards, it takes 12 minutes more for the bath to be full. For the bath to be full. In what time would the waste pipe empty it? In what time would the waste pipe empty it? Right? Let's figure this out now. Simple. I think you don't have to do any more calculation. The only calculation that we need to do in this entire solution is this 24 minutes. Once you have done this 24 minutes calculation, you can now answer the question without putting pen on paper. How do we do that? Just look at it. See, we know that both the pipes A and B together, both the inlet pipes A and B together can fill the bath in 24 minutes. So this person comes after 24 minutes. He realizes that for 24 minutes, not only A and B were kept open, but also the waste pipe was kept open, which was an outlet pipe. So in these 24 minutes, in the first 24 minutes, how many pipes are working? 3 pipes are working. The inlet pipe A, inlet pipe B, and also the outlet pipe. The outlet pipe, which is the waste pipe, right? Even this was working for 24 minutes, in the first 24 minutes. Now he closes this pipe. After 24 minutes, he closes this outlet pipe. Now, when this outlet pipe is closed, only 2 pipes are working after that. Once you have closed the outlet pipe, there are only 2 pipes working after that, right? A and B. It takes 12 minutes more for the bath to be full. It takes 12 minutes more for the bath to be full. See, try and understand. We know that A and B can do the full job in 24 minutes. They can do the full work. Full work is what? 1 unit of work. They can do 1 unit of work. They can fill the bath in 24 minutes. So how much work do you think they will do in 12 minutes? They will do half of the work. Yes or no? If they can do the full work in 24 minutes, in 12 minutes, they will be doing half of the work, which means in 12 minutes more, the bath is full. So what did they do in these 12 minutes? They have done half of the work, which means they have filled half of the bath in 12 minutes. Now, the fact that they have filled half of the bath in this extra 12 minutes tells us that in the first 24 minutes, only half of the bath was full. Already half was full. In 12 minutes more, they have filled the remaining half. Now, in the first 24 minutes, if only half was full, what do you understand? See, ideally, in the first 24 minutes, the bath should have been completely filled because A and B can do it in 24 minutes. But the waste pipe was also open, which means in the first 24 minutes, instead of the full work, they could do only half of the work. Why only half of the work? Because the waste pipe, the outlet pipe, has emptied half of the tank. Yes or no? In 24 minutes, the bathtub should have been full. But we have realized that in 24 minutes, the bathtub was only half filled. Why was it half filled? Because the outlet pipe removed half of the water from the bathtub. In how many minutes? 24 minutes. Which means the outlet pipe can remove half of the water, or the outlet pipe can empty half of the bath in 24 minutes. If it can empty half of the bath in 24 minutes, in what time would the waste pipe empty it fully? In 48 minutes. That's your answer. I hope all of you have followed. It is just one calculation that we need to do. 40 into 60 by 40 plus 60. 24 minutes you get. After this, it is all, your mental understanding. You don't have to put pen on paper. I'll repeat the explanation once again and then also put some steps, because I can sense that some of you may not follow verbal explanation. So I'll put some steps on paper, but let me repeat what I'm trying to say here, right? Because unless you follow this smart method of cutting down, number of steps, and doing the solution mentally, you will not be able to score more in the exam. So it's important that you should be able to figure out the answers without writing all the steps. There are two pipes, A and B, and there is a third pipe, outlet pipe. We know that A can do the work in 40 minutes, B can do it in 60 minutes. So both A and B together can do it in 24 minutes. Whether you follow AB by A plus B or 1 by A plus 1 by B, any method will give you the answer as 24 minutes. Which means A and B together can fill the tank in 24 minutes. A and B together can fill this tank in 24 minutes. That's the first point to be understood. Now this person has kept both A and B open, and he returns after 24 minutes. He returns at the moment when the bath should be full. So obviously he comes at that time. At what time? After 24 minutes, when the bath should be full. But he realizes that by mistake, the outlet pipe was also open. Not only A and B, but the outlet pipe was also kept open. So far. So far means what? For the first 24 minutes. So which means the understanding of the person was A and B are working, but actually A, B and outlet, all three were working in the first 24 minutes. And he now closes it. He comes into the bathroom after 24 minutes. He now closes the outlet pipe. And he finds that in 12 minutes more, in 12 more minutes, the bath is full. So the point is, after 24 minutes, when you close the outlet pipe, only A and B are working. And he says A and B work for 12 minutes for the bath to be full. A and B work for 12 minutes for the bath to be full. To fill the bath. See, we know that A and B together can do the full job in 24 minutes. A and B together can do the full job in 24 minutes. So which means they will do half of the job in 12 minutes. Which means they have filled half of the bathtub in 12 minutes. If they filled half of the bath in 12 minutes, it is obvious that in the first 24 minutes only half of the bathtub was filled. Why only half of the bathtub was filled? Actually, it should have been full, but only half was filled because the outlet pipe was also working. So I can now conclude that in the first 24 minutes, the outlet pipe could remove half of the water from the bathtub. In the first 24 minutes, the outlet pipe could empty half of the bathtub. If it could empty half in 24 minutes, to empty full, it will take 48 minutes. And that's your answer, option 3.